For introduction, logic is the study of argumentation and reasoning. It gives us the guideline and method for identifying arguments that are valid or invalid, which aids in the construction of ideas that are coherent and clear. The law of logic, which provide the fundamental ideas that support logical reasoning, are essential to logic. This law, which controls the framework of acceptable thoughts and ideas, are widely acknowledged facts. Thank you.
Okay, now I will explain a few important laws of logic. First, the identity law. This law says P and T equal to P. If a statement is ended with true, the result is the statement itself. P or F equal to P. If a statement is R with false, the result is still the statement. For example, if P equal to true, then P and T equal to true. And P or F equal true, it skips the original value. Second, the domination law. This law shows P or T equal to T, or with true always give true. P and F equal to F, and with false always give false. No matter what P is, the result is controlled by the domination value, true or false. Next is the idempotent law. This law happens when we combine a statement with itself. For example, P and P equal to P, P or P also equal to P. So, repeating the same value does not change the result. In addition, the double negation law. This law means when we negate a statement twice, we get back the original. Not P, find not P equal to P. For example, if P equal true, then not P is false, and not P, find not P is true. Next, the commutative law. This law tells us that the order of the statement does not affect the result. P or Q equal to Q or P. P and Q equal to Q and P. For example, if P equal to true and Q equal to false, then P or Q equal to true and Q or P equal to true. Same result. So, we can change the order without changing meaning. Besides that, the associative law. This law shows how many groups the statement does not matter. P or Q or R equal P or Q or R. P and Q and R equal P and Q and R. We can remove or rearrange bracket when combining similar operator all or and all and. Then, the distributive law. This law is like multiplication in algebra. It allows us to distribute an operator over another. P and Q or R equal to P and Q or P and R. P or Q and R equal to P or Q and P or R. This helps when simplifying and expanding logical expression. After that, De Morgan's law. This law shows how to distribute negation across a group. Like not P and Q equal to not P or not Q. Not P or Q equal to not P and not Q. This is very useful when dealing with negation of complex statement. Next, the exception law. This law helps to simplify logical expression by absorbing repeated terms. P or P and Q equal to P, P and P or Q equal to P. This means if a statement already includes part of another, we can simplify it to the main part. Then, the conditional identity. This relates to implication. P implies Q is logically equivalent to not P or Q. This form is useful when converting conditional statement into simpler OR statement. After that, the contrapositive. The contrapositive of a statement is always logically equivalent to the original. If P implies Q, then contrapositive is not Q implies not P. Example, if it is rains, the ground is wet. The contrapositive, if the ground is not wet, then it did not rain. Lastly, the inverse. The inverse of P implies Q is not P implies not Q. Unlike the contrapositive, the inverse is not always logically equivalent to the original. Only the contrapositive guarantee the same truth value.
So moving on, we have question number 1. We are given this equation that we need to prove it to equal to P or Q. So the first step is we need to change the position between not P and Q by using the commutative laws. So for the next step is we can use absorption law to get rid of the last bracket until we get Q itself. After that, we can use distributive laws so that we can expand the P and not Q, and also with the Q. After that, we can see that we have Q or not Q, which then we can simplify it so that we get it as true by using inverse laws. And the last one is we have the final answer by using identity laws, which is P or Q.
Assalamualaikum. Today I'm going to simplify a logical impression using the law of logic. For question 2, we have bracket P and bracket R or Q bracket or not Q. Our goal is to make this as simple as possible. First, we can do a much inside the bracket yet. So let's distribute the or not Q into the square bracket using the distributive law. Is equal to both the P term and bracket R or Q term. Look at second bracket. We have all ORs. This allows us to move the parentheses using the associative law. Let's group Q and not Q together. And now what is Q and not Q? That's always true. By inverse law, this simplifies to T or true. We have now next we have the R or true. In logic, anything or true is just true. This is the domination law. Finally, we have bracket P or not Q bracket and true. By the identity law, anything and true is just itself. So our final simplified answer is simplified is P or not Q. Now for question 3, we have not bracket not P or Q bracket and not Q and R bracket or not P. Our goal is to make this as simple as possible. First, we have a negation outside a big bracket. We use De Morgan law and become a or, and we negated everything inside. Remember, double negation on P make it positive. Next, look at the not P at very end. We want to combine it with P in the font. We use the associative and commutative law to shuffle the term around so they sit next to each other. Now we apply the distributive law. We distributive or not P into the bracket. This gives us P or not P and not Q or not Q. Here is the magic. P or not P is always true. That the inverse law. Since true and anything is just anything, we use identity law to remove the T. We're almost there. We see a Q and not Q. Let's group them together using associative and commutative law again. Once again, Q and not Q become a true. Finally, we have true and rest of the statement. In the logic, if all one fact is true in a all true statement, the whole thing is true. This is the domination law. The final answer is just T, true.
In summary, we have learned that simplifying complex statements requires the use of comparable identities, while the examples show that methods can verify without a fixed rule. The laws of logic remain our primary tool for establishing logical equivalences across different problems. So, to wrap things up, remember that simplifying complex ideas is much easier once you apply comparable identities. Don't be discouraged if you don't see a one-size-fits-all method in the examples. Just stick to the laws of logic and you will be able to prove logical equivalence every time.